So here's problem number 15. We are going to do this with respect to y. So as y varies from 1 to 2, of the square root of 1 plus the derivative of y cubed over 6 with respect to y is going to be 3y squared over 6. And then the derivative of this with respect to y is going to be negative 1 half negative 1 over y squared. Would you please check my algebra? I'm not sure I did that exactly right.
Yeah, but you can make that first choice again.
Yeah, we can make the first term. So let's do that. 1 to 2 of the square root of 1 plus, and this is y squared over 2 minus 1 over 2y squared. And this thing is all that squared. All right? 1 to 2. And now let's expand that. So I get the square root of 1 plus, squaring the first term, I get y to the 4th over 4. Multiplying these two terms together, I get 1/4. And then I double it. So I'm going to get a negative 1/8. Oh, double of 1/4 is 1/2. That's right. Duh. Negative 1/2. Yeah, that'll make it work out. And then plus 1 over 4y to the 4th. And then again, this is all dy. Cleaning that up, the only common terms, the only like terms that I have is this 1 and this negative 1/2. So I end up getting the square root of 1 y to the 4th over 4 plus 1/2 plus 1 over 4y to the 4th dy. From 1 to 2. And now the hint, this is a perfect square. What is it the perfect square of? I believe it's the perfect square of y squared over 2 plus 1 over 2y squared. Let's see if that's true. If I square this, I do get y squared over 4. If I square this, I do get 1 over 4 y to the 4th. If I multiply these two things together, again, the y squares cancel, and I end up with 1/2 times 1/2, which is 1/4. But 1/4 doubled is indeed 1/2. So this is a perfect square, and its factorization is that. So this is the square root of a perfect square. So unlikely it seems, those two things cancel out, leaving me y squared over 2 plus, and I'm going to write this as 1/2 y to the negative 2 because I find it easier to do the antiderivative of that. And now I'm ready to do my antiderivative step. The antiderivative of y squared over 2 is going to be 1/6 y cubed. Can someone check that?
Yes.
Okay. The antiderivative of 1/2 to the 1/2 y to the negative 2 is going to be 1/2, and I add 1, I get a negative 1. It's going to be a negative. It's going to be a negative 1/2 y to the negative 1 as we evaluate this from 1 to 2. I add 1 to negative 2. The reciprocal of -1 is -1. I think that's good. All right, and let's plug and chug. 1/6 times 2 cubed minus 1/2 times 2 to the -2. There's me on my upper end. And then plug in the -1.
To the
Negative,
-1.
sorry, plugging in my 1.
No, 1/2 2 to the -1, not to the -2.
Oh, thank you. And then 1/6 times 1 cubed minus 1/2 times 1 to the -1. And I think my parentheses are balanced. So 2 cubed is 6, or sorry, 2 cubed is 8. 8 divided by 6 is going to be 4/3. 2 to the -1 is 1/2. Negative 1/2, or 1/2 times 1/2, that's going to be a -1/4. Over here, I'm going to get a -1/6. And then over here, I'm going to get a -1/2. Common denominator of 12.
I have a positive one somewhere. Oh, you have
Oh, I forgot to distribute the negative signs. So if I distribute the negative signs through there, there's a -6 and there's a positive 1/2. Okay. All right. Common denominator of 12. So 16 twelfths minus 3 twelfths minus 2 twelfths and plus 6 twelfths, giving me a total of 22 minus 5, which is 17 twelfths. Oh, goody. All right. So tomorrow is going to be an in-class work day for the test.